Welcome back. See, in my channel, I usually put videos on machine learning and artificial intelligence. That thing I will be continuing. We will be having more videos on machine learning, artificial intelligence, quantum computing. All these things I will be continuing. Along with that, I today onwards, I am planning to create videos on 11th and 12th physics and math as well. Okay, so today I am going to discuss about vectors, scalars and vectors. These scalars and vectors, when we talk about these scalars and vectors, it is coming in both physics and math. When you cover the vector algebra, it is useful in physics, and at the same time you can use it in math as well. Math also, there is chapters for vectors is there. So you will be getting questions in the competitive exams as well, like NEET, Common Entrance Test, JEE. These exams you will be getting questions from vectors, and you will get both in physics and math. Let's start. So in physics, we usually discuss about quantities and qualities. To understand that, for example, every object falls towards the center of the earth. See, from that, it is a quality. It is every object is falling down. It is a quality. So it is measured by using the gravitational force. It is a quantity. So you have quality and quantity. Understood. Now let's discuss about the quantities, that is the physical quantities. See, physical quantity means, this is the definition. You can listen it properly, or even if you want, you can write it down. Physical quantity means any quantity which can be measured is called a physical quantity. These definitions are important when you write for the CBSE exam. In your board exams, these definitions are really important. So you need to remember these definitions as well for board exams. So what is a physical quantity? Any quantity which can be measured is called a physical quantity. Clear? Now, can you give an example for a physical quantity? You learned it in 9th grade, 10th grade. Many physical quantities you have learned. For example, time is a physical quantity. You measure it in seconds or minute or hours, right? So time is a physical quantity. Mass is a physical quantity. Length is a physical quantity. Velocity, displacement, acceleration, force. There are many physical quantities. You learned it in the 9th grade. You understood that. See, physical quantities have different classifications. One classification you already learned it in, units and measurements. One is the fundamental quantity and derived quantity. So that classification I am not discussing here. See, another classification based on its direction. So physical quantities, some physical quantities have directions, right? So based on the direction, we can classify the physical quantities into two. One is vectors and another one is scalars. Got it? So based on the direction, see, what is this direction? Why it is coming into picture? See, when you talk about mass, see, mass is a physical quantity. You know it. Even you learned it in 9th, 10th grade. You know it. And its unit is kilogram. You know it. See, when you add 5 kg mass, unit is kilogram. 5 kg mass and 10 kg mass, you will always get 15 kg. Understood? Mass 5 kg plus 10 kg, you will be getting 15 kg. But in the case of force, for example, you have a force of 10 Newton in this direction. 10 Newton is in this direction, and another 10 Newton is in the opposite direction. So there are two forces acting on me. One is the unit of force is Newton, you know that, right? You learned it in the lower classes. See, 10 Newton is acting in one direction and another 10 Newton is acting in the opposite direction. So what is the resultant force acting on me? Is there any motion? If both the sides, that means opposite side, 10 Newton each, it is exerted, then I won't move from here, right? Because the resultant force acting on me is 0. You understood? That means force, when you add 10 Newton and 10 Newton, that is 10 plus 10, you got 0. That is because of the direction the force is having. You understood the point? When you add 5 kg mass and 5 kg mass, you will always get 10 kg mass. You won't get 0 kg mass. Mass is not having any direction. But force, when you add 10 Newton force and again 10 Newton force, you will get 0 if it is in the opposite direction. If both are in the same direction, if both the forces are acting in the same direction, you will get 10 plus 10, 20. And if these two forces are mutually perpendicular, 90 degree, then the force will be different. We have formulae for that. So we will learn that formula as well. You understood the point, what I am telling? So from this, you understood mass is having no direction. Mass does not have any direction, but force is having a direction. It's having both magnitude. Magnitude is 10 Newton or 20. Mass 5 kg, 20 kg. 20 is the magnitude. And along with the magnitude, force is having a direction. Such quantities, we call it as vectors. Vectors are physical quantities having both magnitude and direction. Scalars are physical quantities having only magnitude but no direction. And these vectors, they won't obey the rules of algebra. See, the rules of algebra, 5 plus 5 is 10. But vectors, when you add it, 5 plus 5 can be 0. It can be 10 as well. It can be some other answer as well based on the formula. So what we understood here is, one important point is, vectors do not obey the rules of algebra. We need to come up with special rules for addition, multiplication, subtraction, and all the special rules we need to come up for vectors. So scalars, they obey the all the rules of algebra like addition, multiplication, division, everything. Scalars obey the rules of algebra. You understood this? See, what is the important point here? First point, scalars is having only magnitude, no direction. Second point, vectors is having both magnitude and direction. Third point, scalars obey the rules of algebra. Vectors won't obey the rules of algebra. That's why we are coming up with special rules like we will learn it later. Triangular law of addition, cross product, dot product, parallelogram law of addition. All these things we are coming up we are learning for vectors because vectors won't obey the rules of algebra. Again, I am summarizing all the points. Physical quantities. Any quantity which can be measured is called a physical quantity. Example, mass, length, time, electric current, luminous intensity, then distance, displacement, velocity, acceleration, force, work done, all are physical quantities. Now, physical quantities are classified into two. scalars and vectors. Scalars are physical quantities having only magnitude but no direction. Vectors are physical quantities having both magnitude and direction. Clear? So scalars, vectors. The next point is very important. Scalars obey the ordinary, or scalars obey the rules of algebra. Very important. Second point, vectors vectors do not obey the rules of algebra. So we will come up with special rules for addition, multiplication for vectors. So this is the summary. So this is the introductory video for vectors. In the next video, we will be going in detail, in depth for vectors and scalars. Okay, vector algebra. Okay then. Thank you. Thanks.